Okay, so I have the pleasure now of introducing Richard Marston, who retired in May 2016 as University Distinguished Professor of Geography at Kansas State University. Dick earned degrees in geography from UCLA and Oregon State University. He specializes in geomorphology. Hello, Dick.
Geomorphology. Yeah.
Okay, he said it. Geographical hydrology and mountain geography. Dick has pursued studies that separate the effects of human activities on landscapes from changes that would have occurred without human influence. He has studied landform stability and adjustment to environmental change, including the effects of mining, wildfires, deforestation and reforestation, grazing, agriculture, river regulation, and military maneuvers. Dick has been awarded 44 research grants and contracts and has presented more than 420 papers or posters of research results at professional meetings and university seminars. Dick is a recipient of many distinguished awards in his career as a professor, researcher, and lecturer. Please welcome Dr. Richard Marston.
Thank you, Janice, for inviting me to be a speaker today on a part of the world that I really love, both as a tourist but also as a researcher. All right, we're looking here at Nanga Parbat, 9th highest mountain in the world in Pakistan. I'm there with my son, and what can we say about mountains in general? First of all, eye-popping scenery, right? But here, just for reference, that's the peak of Nanga Parbat. This is 14,000 feet from there down this one slope to the base of the mountain. That's the greatest relief on the surface of Earth in one mountain face. So that's the kind of relief you're talking about in the Himalayas. Well, this is an extreme example, but that's the kind of steepness and relief change that makes these mountains so spectacular. But mountains, including the Himalayas, but not limited to them, are features that sustain humanity. The scenery, of course, we've already mentioned, but mountains are also the water towers of the world, is what they've been called, because they collect more rainfall and snow that then ends up running off to the lowland areas of the world. In the state of Wyoming, which you probably are familiar with to some extent, the only areas of the state that have a water surplus are the mountain ranges. And it's because of the snow melt and rainfall in those mountains that rivers exist in the state of Wyoming that not only just exist for water supply, but also are, in some cases, blue ribbon trout fishing streams. That's another talk on another day. So in areas like Pakistan, India, and Nepal, water supply from glacier melt is very important. We'll have some more to say about that later. If you were to be hitchhiking on the International Space Station and flew over the Himalayas, this is what you might see. Right in the middle, see the snow plume coming off? That's Mount Everest. So mountains, of course, are appealing because of the rugged topography. And we think about that if you're walking in the Himalayas for sure. But you know, if you took an orange and enlarged it to the size of the Earth, the skin on an orange is many, many times more rough than the topography on the Earth's surface. So keep that in mind as we walk through this. When you spend time walking in the Himalayas, and I've walked several hundred miles on organized treks and individual experiences, the other thing that strikes you is the imprint of Buddhism on the landscape. Prayer flags, stupas and temples. This is in Kathmandu. Maybe some of you have been to the so-called monkey temple, Swayambanath. And even on the remote trails, you'll pass these stupas every once in a while. Many times these contain the ashes of lamas from nearby monasteries. The other thing that you can't help but be impressed with in the Himalayas are the terraced hill slopes. Now, you often see hill slopes from the bottom to the top that have been completely terraced, probably for millennia. You know, certainly at least 1,000 years, and probably in some cases more than that. Imagine the human capital, the amount of energy and time that goes into maintaining some of this. Remember, these terraces are built by hand and are composed largely of mud. You put 100 or 200 inches of rainfall on a hill slope like this. Without terraces, you'd have enormous erosion problems and certainly wouldn't be able to retain the water for agriculture. But here at the lower elevations, because the terraces have a little bund, it's called, on the edge, they can retain water, and you can grow rice in this case. Higher up in higher elevations where you get less rainfall and the weather is a little bit different, you cannot grow rice, but you still have terraces for crops like maize and potatoes. So these hill slopes are tremendously interesting to me to think about the hydrology. And remember, no one had a PhD in hydraulic engineering that designed and built these. What about agriculture in the Himalayas? It's not like Kansas, where you aren't in Kansas anymore. I've spent the last 13 years of my career in Kansas. So I always smile when I look at this image of the fellow barefoot, a farmer, with a wooden plow being hauled behind an oxen. So that's the kind of agriculture that prevails in the mountain regions, yet they're able to transform these hill slopes into landscapes like this. And if you have a slope failure, a landslide in this case, that takes out some of the terraces, the land is so valuable that they will immediately, the villagers will immediately start to repair it. You might have trouble seeing this, but there are people over here on the other side, and they're starting to rebuild those terraces. Another major human impact in the Himalayas is the construction of roads. Since I first visited Nepal in 1984, the amount of road building is kind of mind-boggling. And here you're looking at the typical pattern of building a road midway along the slope, not along the crest, not at the foot, but midway, which means you have to cut into the hill slope and then the material is cast over the side, cut and fill operations. You see these in every mountain range, but again, imagine putting 100 or 200 inches of rain on a landscape like this. And you can see why mid-slope roads are often creating landslides. They're generating landslides, and it's a major problem. Well, might be interested to know that mountains cover about 24% of Earth's surface, and about 20% of the world's population either lives in mountains or immediately adjacent to them. So just to remind you where we are, we're going to be looking at the Himalayas, this 2,000-mile-long arc here in Nepal, and of course it extends into Pakistan and also through Bhutan and a little bit into Burma, next to India there, and of course India as well. So what about the formation of the Himalayas? Here's a cartoon to remind us that India, the subcontinent of India, was once a separate island, a separate continent really, and it's been moving northward at this breakneck speed of somewhere between 5 and 16 centimeters a year for millions of years. But about 10 to 16 million years ago, it crashed into the Eurasian plate. And that started the uplift of the Himalayas. So how did that happen? When they collided, the crust actually was shortened by about 200 miles. What I mean by shortened is, here's the Indian plate on the left, the Eurasian plate on the right. They collided, and the way the crust was shortened is by these major thrust faults, the main frontal fault, the main boundary fault, and the main central fault. Here's the Tibetan Plateau, which is rising. Even though relative to the Himalayas, there's downward motion. But here you see the major arc of the Himalayas and where it is today relative to these plates colliding. So, keep in mind, 10 million years in geologic terms is a very short period of time to create a mountain range like this. Remember that at the top of Mount Everest, near the top of Mount Everest, is this yellow band of rock that comes from marine sediments. Sediments that were deposited in the ancient Indian Ocean. So in 10 million years, that has come up to over 20,000 feet above sea level. That last diagram I showed you is reproduced down here in a smaller form, but I just wanted to show you as you go from south to north, from the Indian Plate to Tibet, here's what's happening to precipitation. Okay, from the monsoons that come in off the Bay of Bengal every year, rainfall in the lowlands is actually pretty small compared to up in the Himalayas. It actually peaks below the highest peaks. It's in the middle mountains where you get the greatest rainfall, and then it starts to decline. Very dry on the Tibetan side. Here is the channel steepness. So of course, once you get in the Himalayas, they're very steep. Hill slope angle, how steep are the hill slopes, which is going to affect agriculture, the ability to terrace those hill slopes, and the occurrence of slope failures. You see how that changes. And the last one at the top there, that rate of uplift. So these mountains are still coming up, and it shows 8 millimeters per year, which is pretty fast as mountains go, but I'm going to show you some areas that we studied where it's even greater than that. And on the left, your left, you see a computer-generated diagram of present-day India, the Himalayas, and to the north of it, the Tibetan Plateau. And here's Pakistan over here. More detailed diagram. I'm not going to spend a lot of time on this, but it's worth mentioning these major thrust faults again, the MCT, the MBT, and the MFT, the main central, main boundary, and the main frontal thrust by which the Earth's crust is brought near the surface. So what happens is you have an interesting phenomenon in the Himalayas where the more resistant, stronger rocks are, of course, originally formed at depth, but they're brought to the surface and actually in some places overlie the less strong, the weaker rocks which make up the higher peaks. So when you cross this main central thrust, you can identify it in some places because the ground will be littered with these very bluish, platy crystals called kyanite. Any of you familiar with kyanite, what that looks like? You can find it in rock stores. Some jewelry is made of it, and it's a very beautiful and fragile rock. What about the slope failures, the landslides? Here we are in the middle mountains, not the highest part of the Himalayas yet. And we ran across this landslide, which had occurred just a few months before we got there. It came down and dammed up this river. So you see some of the lake sediments that are still left there. It created a lake, and as happens dozens of times per year, you get a lake outburst event where the water cuts through the deposit and you get a flood downstream. Very dangerous, and sometimes takes out structures downstream, but there's rarely any death from these outburst floods because over long periods of time that people have lived in the Himalayas, they know not to have their villages right down near rivers. The other thing might be, it's interesting to mention about this event, we asked the villagers about it, and they said, well, one of the local farmers had been allowing his livestock to run free in the village, pooping in their springs and all over the roads and in people's backyards. And this farmer and his son and some livestock were on this part of the slope when it failed. So to the people in this part of the Himalayas who follow the Bon religion, B-O-N, they thought that was retribution from the mountain gods for this fellow allowing his livestock to run in the village. Here's another rock slide. Look at this one. It came out of this canyon right here and buried 14 people alive. The main trail going up this part of the Himalayas toward Langtang was on this side of the stream, but we had to cross this river and make our way through the forest to get around this landslide that had killed, unfortunately, 14 people. So these are prevalent all over the Himalayas. More recently, just a couple months ago, do you remember hearing about the flooding in eastern Nepal? And this was from the monsoon, which is a rainy season that runs from roughly May through September. Tremendous rains this year, more than normal. And look at the erosion here in some of these mountain villages. I mean, here's the main road that went up this valley. It's gone now from this section right here. So these floods or landslides will block roads and trails and sometimes take them out altogether. Let's take a satellite view of what happens during the monsoon. This is the same area on both sides of this diagram. This is one of the sapped Kosi coming out of India down to the Ganges River. Here is the same scene at the end of the monsoon season, September 11th, 2007. And here's that same river over here. The braided river now is bank full, and here down here is the Ganges, and you see it's also flooding. So this happens every year to some extent. And you can imagine the displacement of people and livestock and the damage to villages and structures that occurs. Think about this. Here's one of the valleys we crossed, and you notice that we're there after the monsoon season. So these terraces, now these are not man-made terraces, these are geologically produced terraces. But if you have land up here, you're okay. But if you had to farm the floodplain, and the caste system is what helps determine this, you see individual fields were separated by rock walls, but during the monsoon season, this area will be underwater, and sediment was carried in and damaged, pretty much wrecked these fields. Maybe you remember this event just a few years ago, 4.5 years ago. Big earthquake, actually two big ones in the Kathmandu area, and hundreds of aftershocks, which created a lot of problems like seismic action, the shaking of the ground, destroying schools and homes, government buildings. So I went up there a couple years ago, took the hike that you mentioned up to Namche Bazaar to survey some of the damage and look at the resilience, what had been done since the earthquake to repair these structures or replace them. Actually, quite a bit had been done. But this one event, well, not just one, because all the aftershocks, you have to consider those too, but it produced 25,000 landslides. Okay, I want you to remember that number, it'll come up again, in just central Nepal, one event. And this was before the monsoon. Can you imagine if this happened in the middle of the monsoon season where the hill slopes were soaking wet with water, and then you add the seismic shaking? Here's another earthquake-related image, going back to a satellite view now. This is the Karakoram Highway, sometimes called the Taliban Highway, going from Rawalpindi. Recognize that name? That's where Osama bin Laden was found. Anyway, this is the major highway. It comes through the Himalayas here. And in 2005, there was a huge earthquake. It was so big that if you look at the epicenter here, can you see that the area I'm drawing in the circle, inside of that has no green? Green is forest vegetation. The forest was completely destroyed in this area, which is about 75 square miles. So it even showed up on satellite images. We drove through this area in 2006, and most of the homes are made of concrete, including the rooftops, which are just flat. And these homes, as you might imagine, just pancaked during that horrible event, which killed roughly 75,000 people. So you see, life is difficult in the Himalayas, right? Well, here's an image. Again, India here, Tibet over here. A late summer image. So most of the white here is not snow, but glaciers. Now, some of this over here is snow, but most of this is caused by glaciers. And what are they doing? Well, as you can imagine, there's a lot of interest with the discussion of climate change. And a study just 2 months ago came out where people were given access to an old US spy satellite. And the spy satellite captured some images going back to 1975. The interesting thing about it is, of course, these were classified for a long period of time. Now they're declassified. This satellite created images that overlapped with each other, which allows you to do 3D measurements. Now, people have been measuring glaciers in 2D for a long period of time. In other words, how has the area changed? And most glaciers are retreating. But they weren't able to measure the vertical change. Turns out that at least half of the ice lost in the Himalayan glaciers is from vertical melting. All right, something that we also found out when we did studies on glaciers in the Wind River Range of Wyoming. So another interesting point of this study is that just in the last 2 decades, let's say since the year 2000, 25% of the ice that was there in 1975 has been lost. 25%, so only 75% remains. And in the last 2 decades, the rate that ice has been lost is accelerating. So now we're going to look at 3 studies that I undertook in the Himalayas. As you look at this computer-generated map again. First, we're going to look at the Manaslu, Ganesh, and Longtong Himals in central Nepal. Then we'll look at Nanga Parbat, this 9th highest mountain in the world. And finally end up with some studies in the Garhwal Himalaya, which is in India. I remember an article in Audubon magazine with this title, and I took great offense because I was also losing hair at that time. But what they're referring to is the deforestation in Nepal and what are the impacts of it. So that was the main reason I went to start to do research in Nepal, is to look at deforestation and was it affecting flooding and slope failures, landslides. Because in the Pacific Northwest, where I was trained in graduate school at the Beavers University, that's a very common link, is if you clear cut the forest, you're going to have increased flooding and more slope failure. So I just assumed that'd be the case in Nepal. When you're walking through the middle mountains of Nepal, it's common to see people carrying loads of wood like this. Can you imagine, I wonder what this guy's back is like nowadays. It's not just men, also women carry loads like this. So they're cutting the forest and taking it along to be used for either construction or fuel. Still 95% of the energy produced in Nepal is from burning wood. So this theory was prevalent at the time, called the theory of Himalayan environmental degradation. The idea was that the population was growing very fast in the mountain areas. So as you go through successive generations of families, the land is being carved up to split among the children, so you would have less land per family, which puts more demand on wood, right? So that might lead to increased deforestation. And like I said, in studies of, well, really around the Pacific Rim, that leads to more flooding and more slope failures. All this water and sediment leaves the Himalayas and goes down to the Ganges River, where it causes flooding, and the channel fills up with sediment. It migrates around, causing problems for farmers, and the same problems also are carried on down to the Delta region in Bangladesh. So again, this was the purpose of my early work out there, was to test this theory. And by the way, if you're losing land by floods and slope failures, there's going to be a feedback creating less land for agriculture, right? All right, so every time we crossed a river, and this is covering 300 miles, moving by foot east and west, we would make measurements to estimate the flood capacity of the channels. So here you see one of our Sherpas, and these bridges, that's the major bridge. That's the major east-west route through the Himalayas. You can see where the water would be during the monsoons, up about this level. There's some nice terraced fields above it, but you've heard the expression, a rolling stone gathers no moss. Do you see any moss on these stones? They're rolling, believe it or not, but so it's a dangerous time of the year during the monsoon to be trying to walk around very much. One of the best ways to spend money in Nepal is building bridges. I remember at several villages, the school was on the opposite side of the river from the village. So, children had to navigate something like this to get to school every day. And we saw some of those villages had new suspension bridges funded by non-for-profit agencies to help make it a little bit safer. Also in the Middle Mountains, as you walk along, you see a lot of these giant, very deep slope failures. And if you were farming in this area, you're out of luck. You can't repair that in any way, unlike that one I showed you earlier on, which is a very shallow landslide. But in the middle mountains, the soils are very deep, and so the landslides can also be very deep. And you notice that here the forest is intact, no landslides. Here it was cleared for agriculture, and here's a big landslide. Fields of mustard in the foreground. So to cut to the chase, after all this work, we found that 83% of the variation in flooding in the mountains of central Nepal could be explained with one variable, just the area of the watershed feeding into the stream. How many square miles above that point in the stream where we measured the flooding? What is the square mileage? The forest cover, as the slide says, added no explanatory power. So it did not matter if the area had a cover of forest or not. And this was quite a shock after having done research, like I mentioned, in Oregon on this topic, where the link between clear cutting and flooding is very well known and documented. So that was the first lesson in the importance of place, that geography matters, that you get in trouble when you translate findings, scientific findings from one geographic of the region of the world to another. You need to go out and collect your own data, what I call muddy boots geomorphology. You have to go out and get your boots muddy and not just rely on what people have done before you. That was with respect to flooding. What about these slope failures, the landslides? I use the term slope failures because it includes all kinds of slope failures, not just landslides, debris falls, rock falls, and so on. So we published a study in this journal, Geomorphology, way back in '98, where we found that the cause of slope failures, the type of slope failures, and their size varied depending where you were. Place matters. Are you in the high Himalaya or the middle mountains? It depends on whether you're on the north-facing slope or the south-facing slope. But look in red here, one of the major findings. There was a lower frequency of slope failures in disturbed lands than an area where the forest cover was intact. Right? Again, just the opposite of what I had learned as a graduate student and researcher in Oregon. So it turns out that, again, the forest cover doesn't really matter. In some cases it does, but overall we found that even with a forest cover, you have very thin soils, and with a monsoon season of rain, dumping 100 to 200 inches of rain on the slope, and the soils are very shallow. Those soils get saturated very quickly, and you can get slope failures. In the areas that are so-called disturbed, many of those are like the slide I showed you earlier of the terraced hill slope. So the terracing stabilizes the hill slope. It's worth the enormous expenditure of cultural energy to maintain those slopes. Do you remember the slide where I mentioned that 25,000 landslides occurred during the earthquake? So we can conclude that earthquakes, especially if they happen during the monsoon season, are more important than human activities generating slope failures in the Himalayas. So going back to this diagram, we do have rapid population growth in the mountains. Land is being carved up, so each family through one generation to the next is getting less land. There are these demands of wood for fuel, for construction, and even the leaf matter is used for fodder for livestock. You do have deforestation, but the form of it is not like a clear cut in the Pacific Northwest. There's a process called lopping, where the local villagers have learned not to cut down the whole forest. They'll cut down 1 or 2 branches off a given tree each year, which then regenerate, and so that tree has a longer lifetime. They've learned this, and so you don't see clear-cut logging in the way we're accustomed to thinking about it here in North America. You do have flooding and slope failures. I think I proved that point already. And you do have these problems down in the Ganges River plain of northern India and the delta of Bangladesh. But the links between these cannot be supported by the data. These occur for separate reasons, not because of this theory of Himalayan environmental degradation. Now let's move to Nanga Parbat, the mountain I showed you at the very beginning with my son in the photo. Here it is, again, the 9th highest mountain in the world. In that picture, by the way, I took earlier on, we were standing right there. So we wanted to, my colleague, Elizabeth Catless, now at the University of Texas, she was interested in how fast the mountains are uplifting. And I was interested in how fast rivers are down-cutting through them. So we went to the Garhwal Himalaya, and she studied these minerals called monzonite, and those could be dated and related to the rate of uplift. And she found some big, maybe quarter-sized garnets in rocks, which can be taken out of the rock and then back to a lab at UCLA and studied, from which it can be determined the rate of uplift of the mountains. So again, as I mentioned, I was interested in rates that rivers were down cutting. And what does this make landscapes look like? Slope failures are an important part. Here's a map of the Bhagirathi River in India and the town of Uttarkashi. And the map here is of the frequency and remaining hazard for slope failures. And can you see that there's a lot of red here and a lot of red here? Guess what those correspond to? This is the main central thrust, big fault, and this is the main boundary thrust down here. So because earthquakes occur along these major faults, you get a lot of mass wasting, a lot of slope failures. But also you get a lot along streams. And why is that? When streams increase during monsoon season, they're undercutting the hill slopes that come down to the stream, right? So that removes the toe of support for the hill slope above it, and you get landslides. The debris is so large that the monsoon floods, even as large as they are, cannot remove all this debris. So the stream starts to increase in elevation, the stream bed, a process we call aggradation. The stream is aggrading. And that means the next year, when the monsoon floods occur, what's going to happen? They're even impacting the hill slopes more. This is a positive feedback, a self-reinforcing process in the Himalayas, for which there's no real engineering solution. Oops. Well, here's some more mass wasting photos in that area. This is the main road going up to the Gangotri Glacier, the headwaters of the Ganges River. You see an enormous rock slide. We were on the wrong side of this. We couldn't get out until the army came and cleared it away. On the right side, you see an image of people going to religious pilgrimages, Hindus going to one of the 5 pilgrimage sites, but a landslide took out the road. So do the people turn around and go home? No, they just stop there and camp until the army shows up and clears the road and allows them to go through. Look at this big landslide here. This entire block slid down the mountain, dammed this river, and the water made a lake up here. Again, it broke through and caused some damage downstream, but most of the village was high off the water, so there were no deaths. This is what it looked like upstream. You can still see the sediments that accumulated behind that landslide dam. It buried a bridge. Pretty dynamic area, right? It's tough living in the Himalayas. So my part, again, was to measure the rates that rivers are down-cutting. And here's what we found. Now, this is a graph of mean elevation against rates of erosion. This is a line for major, that fits the trend line that fits these points. If there is any trend, it's pretty weak, but you see that as you get up in a higher elevation, the rate of erosion increases. But here's where our data plotted for Nanga Parbat and Garhwal. So these were thought to be areas of the Earth that were not experiencing rapid uplift. Well, it turns out they're the fastest growing mountains in the world, and that was one of the exciting things we discovered. This means that you're going to have a lot of river gorges in the world, in this part of the world. So you see the hill slope coming down, and then there's this gorge where the banks are very vertical. So again, look how steep this is. Even in the San Gabriels, they aren't this steep. And you have a gorge here that was created after glaciation, caused by rivers incising very quickly. Here's a close-up where one of these side tributaries is coming down to the major river here, the Bagrathi. And the Bagrathi is down-cutting faster than this tributary can, trying to keep up with it. So it comes down and you have a waterfall where the two join. That's a real certain evidence of rapid river incision. So we're hoping that these studies we've undertaken are putting mountains on the global agenda. Mountains are on the global agenda. On December 11th, put it in your books, your calendars, that's International Mountain Day every year, okay? And it declared by the UN, the United Nations. Not only that, but in 2002 we had the International Year of Mountains. And so these bring attention to all the issues I've discussed here today in the Himalayas and other mountain regions of the world. And if you like scientific literature, the journals that geographers use have had special issues devoted to mountain geography, including this journal I've edited. And here's a special issue of the Annals of the AG. Ray, I'm sure you've memorized this. A special issue, entire issue on mountains that came out a few years ago. I think geographers have a unique perspective to offer on these problems of life in the rugged mountains of the world. We have human and cultural geographers, we have physical geographers, Earth system, tradition, and we have those who practice GIS. All of these subjects are taught here at CSU Fullerton. And where these overlap in this Venn diagram, you have certain types of specialties, each of which is very applicable. It has tools and concepts applicable to understanding the relationship of humans and mountain environments. So that was my plug for geography. So what can we say in conclusion? The modern techniques of measuring rates of change in landforms help place the human factor in perspective. What I mean by this is that it's difficult, very difficult, to separate environmental change due to human activities from change that would have occurred without humans. It's hard to do. And these techniques that geographers use make that more possible. Also, we have learned that hazards aren't the same everywhere. It does matter where you are. Place matters, geography matters, the spatial variability of hazards. Scientists working in the Himalayas and policymakers that use our findings have come to realize that most problems in the Himalayas require training, experience, and expertise in understanding both the physical environment and human systems and how they interact. The bag of tools that we use and the theories position geographers to resolve some of the debates over human-triggered landscape change in the mountains. Remember, what we found was contrary to what we expected to find. So it's a good lesson for teaching students about the scientific method. It works, you know. I would say most studies I've done in my career turned out different than I would have expected. So some of my friends say, well, that's because you're lacking something up here. Maybe, but I think it's because the world is not simple, ordered, and unified. It's complex. It's very difficult to separate the human impact from natural factors. This is a photo I took from a helicopter about a year ago approaching Mount Everest. I have not climbed Mount Everest, but what a great photo. The peak up there. I have a friend who, you remember who was the first person to climb, first two people to climb Mount Everest? Sir Edmund Hillary and Norgay. And a friend of mine went up to shake his hand, and he said, well, you know, Ed, I've climbed higher on Everest than you did. And he was kind of taken aback, and well, that's because he climbed it 20 years after he did, and the mountains are still uplifting. So, yeah, and people who climb it today are the highest they've ever been on the earth because the mountains are still rising. In my career, I've tried to do a lot of work in applied geomorphology, trying to understand human impacts on the environment. This is the highest I ever was. This is not a mountain peak, but it's actually on a road in Tibet. It goes over 18,000 feet. So that's the highest I ever was on Earth right there. And these are great adventures and lots of fun, and I think useful science was generated. But many scientists, especially early after the opening of Nepal in the 50s to outsiders, they would come in and do their work and then leave. And so we have always tried to give something back, either in the way of donations or having Nepalis on our research team and training them as physical geographers, and that has really proven to be a valuable thing in my life. I think I'll conclude with reminding you of a quote from Rebecca Solnit. I bet a few people in here have read books by Rebecca Solnit, like Wanderlust. And she said, and I probably will fumble the exact quote, but that traveling is good because it gives you yourself back. So, it's fun to do adventures, but you also learn about yourself and about other cultures. People who travel to distant parts of the world tend to be more empathetic toward other cultures because they see what difficult situations they have to deal with. So that's been my lasting input or impact of the time in Nepal. The scientific studies were fun, but it really, my time in the mountains there changed me in fundamental ways that are difficult to even articulate. And it's been a joy to continue to work with professors and students in Nepal over the years. So I'll, instead of just saying thank you, I'll thank you in the usual and custom way in Nepal, which is to say, namaste. Probably the best word that was ever invented. It means the spirit in me salutes the spirit in you. Okay, so namaste. So Janice, do we have time for questions?
We have plenty of time.
Okay, any questions? Yes?
Just because I may have missed some of it. As the Indian plate moved north, it subducted under the plate to the north. How much of the mountain range is pressed up from the one plate and how much of it is scraped off the Indian plate as it pushes in?
That's a good question. I don't know that I have the answer off the top of my head. People are still investigating that. We thought that the main boundary fault was pretty inactive. Well, it's not, as recent earthquakes have demonstrated. The rate of uplift of the Himalayas is pretty amazing to look at the elevations you have now generated in the last 10 million years. But also the rates that materials have been eroded off the Himalayas is enormous, as I've also tried to relate with some of the studies. So I can't give you one number offhand, but people are still investigating it because the answer differs depending where you are. And what has changed over the time since the 1980s when I first went there is now geologists and geographers have new dating tools, ways to measure, not just wave at it, but measure the rates of landscape change. And that's what takes time to collect the materials, bring them back to labs, do the dating techniques, but it's happening. And studies are being published all the time. Janice?
So there's a lot of research that is going on in the Himalayas, and have you seen practical application of the results of these studies?
Yes.
Back to the communities?
Yeah. Yes. That's the short answer. Some of the things that come to mind, the road building. Remember I told you about the problems with mid-slope, middle of the slope road building. So that has slowed down. Now, some places you have to do it, but it's a tremendous cost to the government to try to maintain these roads, not to mention building them. So they're trying to build roads, still trying to extend them further and further up in the mountains. But they're trying to build them more on the crest of the ridge with fewer erosional impacts. And the glacial lake outburst floods have been studied, and now we have scientists, Alton Byers is one from the University of West Virginia, who's led a lot of not-for-profit efforts to evaluate the risk for outburst floods and then actually take some mitigation measures. And you know, these mitigation measures don't work if Westerners just come in and tell the local villagers, here's what you need to do. So they're training the local villagers how to measure and monitor on their own increases in lake levels to dangerous levels. When would you have to take some extended measure to prevent an outburst flood? There are probably 100 lakes in the Himalayas that are really crucial and very dangerous at this point in time. So those are the ones that are receiving some priority attention. That's a good example of involving the local community and train them to help resolve some of the hazards that they face. The terracing, really hard to say too much about that. These terraces have been around for a long time, but you know, because they're working during the monsoon season, not too many Western scientists want to be over there battling the leeches and everything else, not to mention the rain, mucking around in the mud, to really measure how do these terraces conduct water from one level to the next without eroding so much. That work needs to be done. And you know, it requires a lot of energy, so these villagers need to have a lot of food to maintain their energy, and there's no real way to supplement that at the present time. So many of these places are so remote that you know, getting a helicopter in there is a difficult thing. Yes?
How about potable water? What's the water supply?
Yeah, the water supply, well, you know, it depends on the monsoon rains and snow and ice melt. And the percent of runoff from snow and ice melt differs depending where you are, east and west in the Himalayas. Rain is more important in the eastern portion of the Himalayas, in eastern Nepal. But in the higher elevations in western Nepal and going into Pakistan, glaciers and snow melt can provide somewhere around anywhere from 25 to 50% of the runoff. So glaciers are dwindling there, as I've mentioned, and so some effort is being placed now to create artificial glaciers where the local villagers will divert a stream and freeze that water and let it melt then during the dry season. So they'll freeze it in the winter at these higher villages and let it melt during the summer. So that's one effort. Why wouldn't you be wanting to put dams on all these rivers? Did that occur to anybody? Why wouldn't you put a dam on these rivers?
Control the flow.
Yeah, you could control the flow for a while, but what's the problem? Yeah, they could use the hydropower instead of burning wood. India is always pressuring Nepal to build dams because India is where the market would be for the electricity. But what's the problem of building a dam in an area like the Himalayas? They would fill up with sediment in no time flat. And also you have earthquakes. You know, so there are a few dams. There's one dam, I should have put a picture in of it. It only goes halfway across the river. And when I got there, I thought, oh, they must have ran out of money or something. No, there's so much runoff during the monsoon season that just having a dam halfway across the river can raise the water to drive 6 turbines for hydropower. And the sediment goes around the dam, right? Because that's where the fastest water would be. So it's pretty clever, actually. And even during the dry season, after the monsoon, these clever villagers built a diversion canal upstream that brings water in a canal to the dams and runs that through the turbines. Pretty clever, yeah. The Chinese built something, instead of building a dam, they built a drain in one of these major rivers. Imagine, you know, a drain like you see on city streets, right? It's got a grill on it. And the idea is that water would go through this, but maybe not the bigger rocks. And so then the drain is connected to a tunnel that goes for 2 miles down the valley, and then the water is dropped through turbines. So there's no dam. I don't know what the cleanup costs are like in this tunnel, but that's another alternative that they've tried. Yes?
I'm still a bit confused. when India was an island, so it was moving along the fault. When it hit the mainland, did it get pushed up or did it submerge?
Well, it's called, yeah, both is the short answer. It's called a suture zone. It wasn't entirely subducted like the diagrams kind of indicate. It's more like there was crumpling and faulting, faulting upward from the Tibetan side. So, we never call that a subduction zone like you have up on the Aleutian Islands in Alaska, where one plate is being subducted, all of it underneath. There's some of that happening, but other things are going on too, folding and faulting.
The density of the rock is about the same on both sides. So there's no reason for one to go underneath it.
Except something's got to give.
Yeah. So the crust has been shortened, as I said, about 200 miles, but it happens by this upthrusting.
So is this upthrust and that created the Himalayan ranges on the Tibetan side, right? So
Yes.
that's how it went from...
Yes. Yeah. It's not as simple as the cartoon I put up there, but that's the major part of the story. You had your hand up first.
You instructed, you were a professor at Kansas State. Did you ever take some of your students? It must have been a cultural shock for them to go from
Yeah, I took some students from, actually it was at Oklahoma State before Kansas State too. Took some from there, from Kansas and from Wyoming. And yeah, it was a cultural shock for all of us the first time you were there, And, the first time I was there in 1984, the population of Kathmandu was, the whole valley was 400,000. So that's what, 35 years ago. And now it's not 400,000, it's 4 to 5 million in the same area. So that's changed, and that was a shock over time. But also once you get out of the valley and you're going up the mountains, the first time we did that, we were going through villages where Westerners had never been. And so the villagers, some of them didn't really want these big trucks coming through their village because we had 18 scientists and 18 Sherpas, and at the beginning, 80 porters carrying our stuff. So they come into the village and the Sherpas want to buy food, eggs and produce, and you could wipe out their food supply. So more than once, the Sherpas were given wrong directions for how to go on to the next village. That's what they told us at the end. They didn't want to tell us that during the trip, but because the villagers, the locals were not used to outsiders for one thing. Some of us were wearing shorts and you're not supposed to do that either. And, we'd set up all these tents in their fields after the harvest, of course. But so, tourists have an impact like that. And some of these villages are so isolated that the language and the clothing would be different from one valley to the next. It was amazing, That's, as you might imagine, that is being blended now more and more over time, but it certainly was a shock at the beginning. I could tell you a lot of stories related to that question, but I'll tell one more. One way that the U.S. has given aid to Nepal in the past is by sending over Peace Corps workers. And one of the things the Peace Corps workers did, not the only thing, but one thing they would do would be to hand out birth control, condoms, But we could go into these villages and they were being used as balloons by the kids. The men didn't want to use them. And so, the average size of families was 5 children and one either miscarriage or infant mortality per family. So, because of the population growth and the health concerns and the lack of land, there was this thought that you could help out with birth control, but that didn't really take. Another effort that didn't really go well was to try to replace these smoldering fires in the homes, which creates an enormous amount of smoke and lung problems, replace those with wood-burning stoves. So what do you need for wood-burning stoves? They don't work on twigs like the fires would. You need cut wood. So it actually increased the rate of deforestation around the village. You could see it on satellite images. And so the second time we went through these villages, we crossed a bridge and we saw all of these wood-burning stoves that had been thrown into the gully. You know, and the villagers said, this was the worst thing that ever happened to our village. You're trying to help us, we understand that, but we had no use for these because they contributed to our loss of wood. And there's other stories I could tell, but yeah, there are, what would you say, cultural conflicts or not understanding the real needs of these villages. Yes?
The water issue must affect everything outside of Kathmandu, which in turn forces in a migration of those people in search of water. And as the temperature rises, has any studies been done on the movement of people out of the outskirts of Kathmandu and beyond? Those people moving back into the city, thus the growth of the city, 4 to 5 million, stated, has begun to grow, and of course using the resources for that, you know, in order to survive.
Yeah. There has been a lot of migration from the mountains into Kathmandu and other cities in Nepal. It used to be that 90% of the population lived in the mountains in Nepal. That's no longer the case. I don't know what the exact number is, but it's going to be maybe 70, I'll say, something like that, 60 or 70. There's been a lot of out-migration, not just because of water and other environmental issues, but actually more because of the Maoists. The left-wing militias, they call themselves the Maoists, not after Mao, you know, in China, and very violent, and they would go into villages and ask for one son from every family to join their army, whether they wanted to or not. And, you know, they overthrew the government. Now they're part of the government. The Maoists are, the parliamentary system they have in Nepal, modeled after Britain. So, but that drove a lot of people out of the mountains, especially in western Nepal, where the Maoist insurgency began. So that maybe is even more important than the environmental factors. Also, the fact there now is for the first time a cash economy in Nepal. It used to be everything, including food and wood, and was exchanged in a bartering system. And now men have been recruited to work on construction projects like roads, mines, and also, you know, plane loads of Nepali men fly to Dubai on every Monday, and they come back on every Friday. I've been on those flights, and I was the only non-Nepali on the flight, so I could ask about what was going on. And they make major money when they work in Dubai on construction projects. So that has caused kind of a drain of men from these mountain villages, not just the mountains, but the cities also. And one of the striking things about Nepal is when you hike around, you realize that the agriculture, and really in some cases the entire village, is run by women. And they're the ones out there planting, so they're doing the farming. Their children are helping. Their young children will be babysitting the infants, but the whole family is working. The men are gone to other cities or even to Dubai. And the net effect has been that women have kind of taken over the local economy in the mountains. Okay, well, I'll be glad to stay around for a few minutes, but thank you again.